All right, so this is our video for 7.2, converting from a radical to a rational exponent. Okay, so first of all, we have a couple of questions in our notebook. What is a rational number? Remember, a rational number is a fraction. So we kind of already looked at rational exponents at the beginning of the last section for 7.1, where we were looking at how the index number becomes part of the exponent in terms of a fraction. So if you guys remember, where does the index number go in the rational exponent? That was in the denominator. And then what needs to be done if the rational exponent is an improper fraction? We also looked at that in terms of when we were simplifying a radical, we were dividing the exponent on the inside by the index number. So we were basically setting up an improper fraction. And so we change it to a mixed number. Okay. And then remember, so if we had, let's say x to the a times b over c, that's not a c right there. That's what we ended up getting when we changed it to a mixed number. Then we said x to the a, and then we changed this to the c root of x to the b. But in terms of keeping it as a rational exponent, we change it to x to the a times x to the b over c, like that. So we basically undo the product rule. And sorry, this shouldn't be a times right here. It should be a and b over c. So this is actually, this should be a plus right there. Okay. So now, converting root to a rational exponent. We're going to use that whole idea of how the index number is going to become the, basically the denominator of the exponent. So first we want to rewrite this as the cube root of 2 squared x to the 7th and y to the 8th. Then what that becomes is 2 to the 2/3 times x to the 7/3 times y to the 8/3, and then we only have two improper fractions here. So this is going to stay 2 to the 2/3. X is going to become x to the 3 goes into 7 twice with the remainder of 1, so and 1/3. And so then we have y, 3 goes into 8 twice with a remainder of 2, so 2 and 2/3. And so then what this happens to be is 2 to the 2/3 times x squared times y squared times x to the 1/3 times y to the 2/3. Okay, so same thing here, except this time we're looking at the 10th root. So 173 is actually a prime number, I believe. That means that this is really just going to be to the 1 power. We do have this negative exponent here, so we do want to simplify that. So we're going to say the 10th root of 173. We move that exponent up, so this moves up here, and then it becomes x to the 9th. So this is actually going to give us x to the 50th power, and then we have y to the 17th. So when we write this with putting the index number in the denominator of the fraction, so with a rational exponent, we have 173 to the 1/10 power times x to the 50 over 10 power times y to the 17 over 10 power. This is going to stay 173 to the 1/10. This one simplifies to x to the 5th. Then this one simplifies to y to the 1 with a remainder of 7, so 7/10. So we would say 173 times 1, or to the 1/10 power, times x to the 5th, times y to the 7/10. Okay, now go ahead and take a moment to pause your video here and see if you can simplify these ones down as far as you can go into rational form. All right, so just go ahead and compare how you did. I've got basically two forms of the answer for both of these. So let's go ahead and talk about it. So I broke this down to 2 to the 4th, but you could also have just written it as 4 squared because you had an exponent of 2. Just so you know, but I always try to bring my numbers down to the smallest numbers as possible. It's just kind of the way my mind works. So anyways, we go through, we take the exponents, we divide by 2, we simplify to this, and then we get 4x squared, y to the 7th, x to the 1/2, and y to the 1/2. How I got this number is basically kind of, since both of these are raised to the same power, I can put them in parentheses and then raise it to the 1/2 power. So this is kind of like another simplified form of writing that answer with the simplified rational exponents. In this case, with the 21, because it's 21 to the 4th, I know 21 breaks down to 3 and 7, so I could also write it as 3 to the 4th and 7 to the 4th. But since neither of those are going to be divisible by 17, I just left it as 21. So I have 21 to the 4 over 17, x to the 33 over 17, and then also we had this negative 2 here, so we moved the y down to the denominator, so we have y to the 2/17 power. 33 was the only one that's divisible by 17, so that's where we got our mixed number there. And I'm sorry, I actually didn't simplify that. That one is not an actual simplified version there. So let's go ahead and get rid of this right here. So that's a 17. This actually should simplify to 21 to the 4/17 times x to the 16/17 over, this is supposed to be a y there and it got delayed, y to the 2/17. And then what happens here is I've got all of these fractions with 17 in the denominator. So what I can do is I can take the whole x out, and then I can put everything else with 17 in the denominator of the exponent. I can factor out that 1/17 right here. So I'm kind of undoing the power rule, and then write the other numbers, so 21, x, and y, with just their numerator exponents inside of the parentheses, and then the 1/17 to represent the denominator on the outside. Either one of these answers would be appropriate. All right, so let's kind of finalize this. Steps for converting a radical to a rational exponent. Okay, so first step is that we want to simplify the numbers into their prime factors raised to a power, so that we can actually simplify any of those numbers raised to a power divided by the index number or by the denominator when we go into the whole process of simplifying. So that's the first thing we want to do. Second step is to rewrite every factor of the radicand into, that's the primes and variables, into individual factors with an exponent of the inside exponent over the index number. So we're going to basically rewrite them all with rational exponents. Now, if any of the rational exponents are improper fractions, sorry, I already said that, convert those improper fractions to mixed numbers. Now, one thing, while I was typing this up, I realized I wanted to change step 2 and say rewrite every factor with the primes or variables with a rational exponent. So we want to make sure that the exponent is a fraction with the inside exponent over the index number. Okay, so we convert any improper fraction into mixed numbers, and then we go ahead and we want to write the mixed number as a product of the number or variable with an exponent of the whole number times the number or variable with the exponent of the proper fraction. So basically we're splitting up the mixed number exponent into the whole number and the proper fraction. And then finally, we want to just to be able to put things together, we want to simplify numbers to whole powers, and then group the variables with whole exponents first, and then group variables with fraction exponents last. All right. Page. Okay, so we've got a couple of problems. We want to simplify these rationals or radicals. So we're actually doing the opposite here. We've been simplifying radicals to rationals, but we want to show that you can go the other way as well. So again, we want to go ahead and because we want it to be a simplified radical form. So we want to go ahead and rewrite 32. 32 is 4 times 8, which ends up being 2 squared times 2 cubed. So this is actually 2 to the 5th power times x to the 4 thirds times y to the 5 thirds. Okay, so this doesn't have an exponent, so we could have left it as just 32 because it's not going to go inside of the radical. It doesn't have a denominator, so it doesn't have an index number. So we're going to go ahead, but it's always good to practice prime factorization. So we're going to go ahead and write this as 32. We're going to rewrite x to the 4 thirds is equal to x to the first times x to the 1 third. So we got x on the outside, and then we're going to have an index number of 3, and x to the first power on the inside. Y to the 5 thirds is equal to y squared times, sorry, not y squared. That 2 is my remainder. Y to the first times y to the 2 thirds. So this means that we're going to have y to the first on the outside and then y squared on the inside. So this is 32 xy cube root of xy squared. Okay, on this problem, we actually first want to go ahead and do the power rule, distribute the 6. So we've got a to the 1 third times 6. Remember, the denominator basically means divide, so we're doing 6 divided by 3. So that gives us a squared times b. This is going to, 6 divided by 2 is 3. And then c to the 5 6. 6 divided by 6 is 1, and then times 5. So in this one, when we simplified it, because there are no longer any denominators in our exponents, we actually can't convert this to a radical. There's not a radicand involved. Okay, so now go ahead and pause the video and see how you do on these problems here to be able to convert them into radical form. And then hit play to see how you do. Okay, so on these problems, remember, really, anytime that we're going to have a whole number outside of the radical, it's because the numerator or the original exponent is greater than the denominator or the index number. So on this case, this is a proper fraction, this is our improper fraction, so y is the only one that's going to have a value outside of the radical. So when we simplified this to a mixed number, we had 1 and 2 thirds. So that's where that comes from. So this y to the first power goes on the outside, and then everything else with a denominator of 3 is going to go on the inside. So this is what we can write that as, or because both of these are squared, we could also write it in this format. So 16 is equal to 2 to the 4th. Sorry, I forgot the 1/5 here. And so we just rewrote that. Now what you can see again here, all of these exponents on the inside are actually less than 5. So they're all going to be, if we did the power rule, they would all be proper fractions already. So nothing is going to simplify to a mixed number. So we can go ahead and just take this 1/5, write it as the 5th root with everything that was inside of the parentheses as our radicand. So here's this version, or if you don't want to write it as 2 to the 4th because nothing's simplified there, you could also write it as 16 times x cubed times y to the 4th. Okay, negative roots. When can you have negative roots? We kind of already talked about this. This all has to do with when the root is odd and the radicand is negative. Or in terms of like a rational exponent, when the denominator of rational exponent is odd, and base of b to the x over n, so the b right there, is negative. So we're talking about something like negative 16 to the 2/3 power or something like that. Then you can have a negative root. All right, so again, some more simplifying. Go ahead and see how you do on this one. Pause the video and then go ahead and compare your work to mine. Okay, so you can see here, again, you want to simplify your numbers. You want to do prime factorization to rewrite them in terms of a prime raised to a power. So what we have here is 32 is equal to 2 to the 5th, 25 is equal to 5 squared. Then we go ahead and basically divide all these exponents by the index number. So we're going to get 2 squared and on the outside, and then 2 to the first on the inside. X squared on the outside, x to the first on the inside, 5 on the outside, and there's no remainder, so no 5 on the inside. Then y to the 4th on the outside and y to the first inside of the square root. And then go ahead and simplify our numbers. So 2 squared is equal to 4, so we got 4x squared over 5y to the 4th times the square root of 2x over y. Okay, rewriting 1250 and 162 in terms of their primes, it's actually equal to 5 to the 4th times 2 and 3 to the 4th times 2. Then we can go ahead and divide out those 2, so we're left with 5 to the 4th and 3 to the 4th times their variables. So we go ahead and divide every exponent by 4. We get 5x squared, y squared over 3, and then we have a remainder of x to the first, y squared, and the z, because it has an exponent of 2, which is smaller than 4, is not going to have anything on the outside because it's not going to have a mixed number. So we have z squared, and then this is just really rewriting it so it looks a little neater. Okay, now simplifying rational exponent expressions. Here's just a couple, like applying the product rule and the quotient rule in this case, or the negative exponent rule. So what we've got is we've got to be able to add these exponents. So this is x to the 1/2 plus 1/4. So we need a common denominator, which means we're going to multiply this by 2 over 2 to get an exponent of, or denominator of 4. So this is x is equal to 2/4 plus 1/4, which is going to give us the answer of x is equal to, or equal to x to the 3/4 power. Okay, in this problem, we know that this would be 4, and then we can move the exponent down, so x to the 2/3 times x to the 1/3. So that gives us 4 over x to the 2/3 plus 1/3. Which is going to give us the answer of 4 over x to the 3/3, which simplifies to 4 over x to the first power, or x. And so that's basically going over rational exponents, also reviewing simplifying radicals, and being able to work with both of those different forms of essentially finding the roots of numbers.